Hi everyone, we are from Group 2 and today we will be presenting our analysis on Fluffy Bread Co. Fluffy Bread Co. is a mid-scale bakery producing buns, loaves and various types of pastries. The company operates 6 days a week and distributes its products to mini market, cafes, convenience stores and home customers across Selangor. The production process is divided into 3 main departments, which is first, assembly department, handle dough preparation including mixing, shaping, proofing and baking. Second one is packaging and finishing, wraps and label products for delivery. And last but not least is quality control, ensure product consistency in size, texture and appearance. Even though the company has partially implemented automation, it still faces several operational challenges. First is delivery delays, inconsistent product quality, bottlenecks in production stages, and lastly is manual inventory management leading to overstock or stockout. These issues affect productivity and customer satisfaction. The objectives of this report is to analyze the company's operations and propose improvement using productions and operation management concept, including process capacity, process planning, inventory control, quality control, and lean principles. Fluffy Bread Co. uses a batch-based production system planned according to daily demand forecasts. Production combines semi-automated machines like industrial mixers and ovens with manual processes such as dough shaping and portioning. The mix of manual and automated process causes inefficiencies, bottlenecks at certain stages, and variation in product quality. To understand this better, we analyze each stage of production. The process starts with raw material receiving. Fluffy Bread Co. receives ingredients such as flour, sugar, yeast, butter, milk, and also packaging materials from both local and national suppliers. Once these materials arrive, a basic visual inspection is carried out to check for any damage or quality issues. After that, dry ingredients are stored in a designated dry storage area, while dairy products like milk and butter are kept in refrigerated storage. However, the main issue here is that inventory recording is still done manually. Because of this, the company often faces situations where there is either too much stock or not enough materials to continue production. This can slow down the production process and also increase inventory holding costs. Next is the dough mixing process. Ingredients are weighed according to the recipe specifications and mixed using industrial mixer. During this stage, some manual handling is still required, which can result in variations in dough quality from batch to batch. Another issue occurs when the mixer capacity does not match the production volume. This leads to downtime when the mixer cannot handle the workload, or in some cases, excessive dough is produced at one time. Both situations create inefficiencies and affect overall production. After fermentation, the dough moves to the shaping and portioning stage. At Fluffy Bread Co., this process is done manually. The dough is shaped into different products such as buns, loaves, and pastries. Since this step relies heavily on manual labor, it takes more time and often results in inconsistency product sizes. This inconsistency not only affects product quality but also creates delays. As a result, this stage frequently becomes a bottleneck, causing congestion in the proving and baking process that follow. Once the dough is shaped, it is placed in proofing enclosure to rise before baking. Ideally, proofing time should be closely monitored. However, at Fluffy Bread Co., proofing times can vary due to scheduling issues or insufficient monitoring. When proofing is not consistent, the dough can become overproof or underproof. This directly affects the volume, texture, and appearance of the final product, increasing the likelihood of defect being detected during quality control inspection. The next stage is baking. Proof dough is baked using industrial ovens, and baking time depends on the types of product and batch size. One of the main challenges here is the limited oven capacity. During peak production periods, oven space becomes a major constraint, leading to congestion. This causes delays not only in baking, but also forces the previous stage, such as proofing and shaping, to slow down or stop temporarily. After baking, products are transferred to cooling racks and left to cool for approximately 20 to 30 minutes before packaging. However, the cooling area has limited space. When too many products are produced at once, congestion occurs at the cooling stage. This causes products to remain on the rack longer than necessary, which can slow down the downstream packaging and finishing process. Once the products are cooled, they go through quality control. The quality control team inspects the product based on several criteria, including color, texture, shape, and overall uniformity. During peak production periods, the number of batches increases, which significantly raises the workload for the quality control team. This results in slower inspection processes and creates delays before products can move on to packaging. After passing quality control, production proceeds to packaging and finishing. Packaging involves sealing the products using semi-automated machines, while labeling is still done manually to include product and expiry information. Delay often occur at this stage when the product accumulate while waiting for quality control approval. This creates a backlog of order and slow down the overall order fulfillment process. The final stage is distribution and delivery. Finished products are loaded into delivery vans and sent to retail stores, cafes, and wholesale customers. Any delay that occur in earlier stages, such as shaping, baking, quality control, or packaging, will directly affect the delivery schedules. As a result, late deliveries become a recurring issue for the company. So to summarize the process analysis and make it easier to visualize, this flowchart shows the complete production process at Fluffy Bread Co., starting from the raw material receiving all the way to distribution and delivery. It's also helped highlight where delays and bottlenecks are most likely to occur throughout the production flow. So I will pass this over to my next presenter to continue with the explanation.
Assalamualaikum. My name is Nuri HUMAIRA Pitim Anasi and my metric number is 300145. I'm about to present capacity planning. Capacity planning is about to provide the capability to achieve the customer demand that is reliable at a controlled cost and waste. Also, proper capacity planning minimizes inventory shortage, overproduction, and promotes high profit growth. Demand forecasting and seasonality mixed forecasting strategies such as SARIMA. SARIMA known as Seasonal Autoregressive Integrated Moving Average. It was a model that tracks long-term trends and seasonal spikes. For example, higher bread consumption during school terms versus holiday. Another one is machine learning and causal inputs. It was using AI to factor in why sales change, such as rain, increasing bread consumption, or a competitor's price drop. Operational rhythm, moving from monthly plans to rolling horizon forecasts, which is about continuously updated to stay agile. Risk management is using safety stock policies to ensure shelves are not empty, while acknowledging forecast uncertainty to prevent overbaking. Last one, goal. It was about capacity right sizing, which is matching of an output to hunger, and waste reduction, about to reducing returns of unsold and expired bread. The equipment and process capacity will be taken into consideration. Process analysis is about measuring cycle times for how long one loaf takes from dough to bag, and throughput about total loaf per hour. Bottleneck identification, which is about finding where the clock is, usually the ovens or cooling racks, which is bread must cool before baking to prevent mold. Optimization, which is FCS, known as finite capacity scheduling, that ensures you don't schedule more dough than the ovens can physically hold. Max span optimization aims to finish the total production run in the shortest time possible. Last one is efficiency. It's about reducing idle time, which is machines running empty to save on high Malaysian industrial electricity tariff. Workforce planning and training. Cost control is using workload-based rostering, so you don't pay overtime when demand is low. Structural planning. It was about a skill matrix tracks who can operate which machine. Peak period vetting ensures enough staff are available during festive seasons like Hari Raya. Flexibility, it's about cross-training workers so a packer can help with dough mixing if someone calls in sick. Last one is alignment, which is need to ensuring staff shift match demand pattern. Synchronization, for example, starting the graveyard shift early so fresh bread hits Malaysian grocery stores by 7 a.m. Inventory and raw material strategy. perishability management, which is FEFO, first expiry, first out, ensures the older flour and yeast are used first to prevent spoilage. System is an ERP, enterprise resource planning, which is system that tracks shrinkage, about loss or wasted ingredients, and sends expiry notifications. Supply chains agility is matching lead times for imported ingredients like high protein wheat while keeping ingredient buffers for essentials like sugar or salt. Process improvement and lean approach methodologies is about lean manufacturing, eliminating waste, and Six Sigma to reducing defects like burn or mishapen loaf. Waste elimination, removing muda Japanese for waste such as motion about workers walking too far to get grades or overproduction. Responsiveness, value stream mapping helps visualize the flow from flower delivery to the delivery truck. Agility, SMED, single minute exchange of die, refers to quick changeovers, which is switching the production line from white bread to wholemeal bread in minutes rather than hours. The investment in automation and technology, targeted automation, investing in devices which is splitting dough accurately, proofing tunnels about controlled environment for dough to rise, and depositor lines, which is placing dough into tins. Digital integration, dough scheduling software calculate exactly when to start mixing so the dough does not overproof while waiting for an oven. Lastly, financial validation (ROI), return on investment analysis, calculates if the cost of a ringgit Malaysian 1 million automated oven is worth the savings in manual labor cost elimination.
Inventory management is essential for the company because it uses highly perishable materials. The key ingredients must be carefully monitored to maintain product quality and prevent losses. Currently, poor inventory control has led to several problems. First, stockout occurs when ingredients run out unexpectedly, causing production delays. Second, overstocking happens when excessive quantities are stored, increasing the risk of spoilage. Third, high wastage is experienced due to expired or improperly stored ingredients. At present, the company relies on manual record keeping, which is inefficient and prone to errors. Therefore, a proper inventory management is needed to ensure smooth production operation, improve cost efficiency, and maintain a consistent supply of raw materials. The company currently faces several inventory management issues due to manual monitoring and lack of digital record keeping. Inventory decisions are often made based on intuition rather than accurate data, which reduces efficiency and increases risk. There is no consistent data on important factors such as raw materials consumption rates and supplier lead time. As a result, demand forecasting is poor, leading to frequent overstocking or overstock out. Overstocking causes spoilage of perishable materials, while stockouts result in production delays. Additionally, the company frequently places emergency orders to compensate for shortages. This urgent purchase increases procurement costs, which sellers often charge premium prices. Overall, inefficient inventory management leads to wastage, cash flow problems, and inconsistent production volume. To improve inventory efficiency, the company needs to implement economic order quantity model. EOQ helps to determine the optimal ordering quantity while minimizing total inventory costs, including ordering and holding costs. Several key actions are required to ensure effectiveness of EOQ model. First, the company needs to collect the accurate demand and cost data. Secondly, daily and weekly raw materials usage should be tracked consistently. In addition, monthly consumption trends need to be recorded to support better planning and forecasting. Order points need to establish based on supplier lead times to avoid stockouts. To support this process, the company should use a simple digital inventory system or spreadsheet instead of manual records. Furthermore, inventory should be categorized based on priority. High priority items include flour, yeast and butter, which are critical to daily production. Low materials items include packaging materials, which are less time sensitive. Finally, the EOQ calculation needs to be reviewed quarterly to reflect changes in demand, cost, or supply performance, and to ensure continuous improvement in inventory management. The implementation of recommended inventory management improvement are expected to bring several positive outcomes. First, emergency order will be significantly reduced, leading to lower procurement costs. Inventory holding costs and waste will also be reduced due to better planning and control. Improved inventory management will enhance production continuity, ensuring production runs smoothly without interruptions. This will result in product availability for customers and increased customer satisfaction. In addition, improved inventory control can strengthen the cash flow management by reducing unnecessary capital tied up in excess stock. The cost saving achieved can be reinvested in equipment upgrades, staff training, and product development. Furthermore, more structured ordering and communication will help build stronger and more reliable relationship with the customer. Overall, this improvement will lead to a greater operational efficiency and long-term business sustainability.
And now, we will look into the quality control. Why it is important for us to bring up this topic? Because it is important for the client to ensure the quality will be same all the time. So, in this case, I personally do recommend to use the Six Sigma procedure, which will help them to keep the quality for both short and long term. First, we will define what is their problem. So, in this case, we know that they always receive a complaint from their client, which is the quality bed is poor. So what do I mean by poor is the clients always receive a raw or burnt bread. After we know what the problem is, we will measure them. Why we do measure? So we can collect the precise data, and we will record and collect the data from the start to the end. And I do recommend to take maybe few weeks of data. And with the data, we can analyze them. And we will dig deeper to find what is or what are the causes in the inconsistent quality. So with the data, I made the fish diagram so we can look into deeper problems. So for example, I took one which is the material problem. The dough itself doesn't have a moisture ventilation, a proper moisture ventilation. And after we know what are the causes, we can improve them. We can start to fix the causes, starting with the material itself, because I believe the main problem is the dough itself. After we improve them, we need to control the quality. And how we do it is we prepare a proper SOP, standard operation process, for a future convenience and to minimize the defects itself.
Supply chain issues is supply chain disruption effect over operational performance. For the key issue is delayed supply deliveries, inconsistent lead times, and fluctuating raw materials quality. And for the impact is higher operational costs, production delay, and idle time in assembly. And the last one is late deliveries to customer. Communication gap with supplier, and for supply chain analysis and improvement. And for current supply chain flow, for the main problem in the flow is supplier delay cause congestion at receiving, long waiting time at QC, and for the effect is unstable production output and poor delivery performance. And for the problem identified is late delivery of raw materials, not formal supplier evaluation system, increased cost due to urgent orders, poor communication and lack of demand for recast sharing, suppliers unprepared with sufficient stock, inconsistent raw materials quality, and no fixed delivery schedule causing congestion. For recommendation for improvement is establish long-term strategic partnership with key suppliers, improve demand forecasting accuracy, share monthly or quarterly forecast with suppliers, implement safety stock and reorder point, prioritize local supplier to reduce lead time, set fixed delivery schedules, and adopt digital supply chain monitoring. And for the implement a supplier evaluation or vendor rating system is on-time delivery, quality consistency, lead time reliability, and the last one is price stability and responsiveness. For the expected outcomes, higher on-time delivery performance, reduced production delays, smoother workflow across departments, lower downtime due to material shortage, reduce operational costs, shorter production cycle time, improve customer satisfaction, stronger and more sustainable supply chain, and the last one is more consistent raw material qualities.
Now, I will continue with cost and time reduction at Fluffy Bread Co. Currently, the company is facing high operating costs and long production lead times due to inefficient workflows, bottlenecks, and weak inventory management. To overcome these issues, Fluffy Bread Co. can apply lean manufacturing principles, process re-engineering, and targeted automation. These strategies aim to reduce waste, shorten production time, improve consistency, and lower overall operational costs. Lean manufacturing focuses on identifying and eliminating non-value-added activities in the production process. At Fluffy Bread Co., waste such as overproduction, waiting line, excess inventory, unnecessary movement, and product defects can be significantly reduced by improving the scheduling of proofing, baking, and cooling processes. Idle time for ovens and production lines can be minimized. In addition, implementing a pull system ensures that raw materials are supplied only when needed, instead of being stored in large quantities. Standardizing operating procedures for the shaping, portioning, and packaging will reduce variation and errors, resulting in a more efficient and reliable production flow. Process re-engineering involves redesigning key production steps to remove bottlenecks and increase throughput. For Fluffy Bread Co., the dough dividing and shaping process can be enhanced by using semi-automated dough dividers and molds. This reduces dependence on manual labor while improving speed and consistency. Automated proofing systems with controlled temperature and humidity can ensure uniform dough fermentation and prevent quality issues. Furthermore, conveyor systems and automatic labeling machines can speed up the packaging process. Overall, process re-engineering helps shorten production cycle, reduce labor costs, and improve product quality. Effective inventory management and supply chain coordination play an important role in reducing costs and delays. By implementing a just-in-time inventory system, Fluffy Bread Co. can order ingredients based on actual production needs, reducing storage costs and minimizing waste of perishable materials. Better coordination with suppliers, including fixed delivery schedules and accurate demand forecasts, can prevent production stoppage caused by late or insufficient supplies. In addition, using an ABC inventory classification system allows the company to prioritize critical and high-value ingredients, ensuring availability without tying up excessive capital. Investing in technology and automation can further support cost and time reduction efforts. Upgrading to higher capacity and energy-efficient ovens can increase production output while lowering energy costs per unit. Automated dough dividers and labeling machines reduce the need for manual labor and improve consistency. Digital tracking systems and dashboards enable real-time monitoring of production progress, allowing management to quickly identify delays, defects, or even bottlenecks. These technologies support faster decision-making and improve overall operational control. With the implementation of lean principles, process re-engineering, inventory optimization, and automation, Fluffy Bread Co. is expected to achieve significant improvement in efficiency and cost control. Production cycle time from dough preparation to packaging will be reduced, leading to faster turnaround and more reliable deliveries. Operational costs will decrease due to lower labor requirements, reduce waste, and improve energy efficiency. Product quality and consistency will also improve, resulting in higher customer satisfaction. Overall, these strategies will strengthen Fluffy Bread Co.'s competitiveness in the bakery industry.